to the Funtastic Academy. With me, Ayush Prasad. Hello everyone, welcome to the Funtastic Academy with me, Ayush Prasad. Now, last episode we talked about electromagnetic waves. Today we're going to continue this journey by reuniting two different corners of the spectrum, microwaves and X-rays. Microwaves are big, X-rays are tiny. We're going to talk about both of them in this episode. But first of all, I need to answer last episode's quiz question. What is the unit of frequency in light waves? The answer is hertz. Hertz measure things per second. In the case of frequency, cycles. It measures 1 divided by s, seconds. So, Hertz is named after Heinrich Hertz, a German scientist who made a lot of things when it comes to radio waves. So, we are going to be talking about micro and X-rays. So, stop beating around the bush and let's get started. Micro is a very silly name for these waves as their wavelengths are still rather big. Now, they're not as big as radio waves, but compared to other waves, they're gigantic. So, how do microwaves cook your food? Well, let's trace it all the way back to Percy Spencer. He was working in the radar department in the US military. The radar department is supposed to use radio waves, but they were experimenting with microwaves. And one day, he was sitting next to a microwave generator where he felt something sticky in his pocket. You see, he had left a chocolate in his pocket for eating purposes, but the microwaves had heated it up and melted it. Now, why can microwaves do it where no other waves can? You can't shine a bright visible light on chocolate and make it melt. Why microwaves? Well, to learn it more in depth, we'll need to learn about resonance and quantum physics and all of that. But in simple terms, a microwave is just the right size that it can jiggle water molecules a lot. Other waves can jiggle water molecules, but microwaves are a size where they can jiggle it the most. And it turns out, a lot of your food is water. And when the water molecules jiggle, they make all of your food jiggle. And you know what happens when molecules jiggle? Heat. And that's how microwaves can cook food. They use a special device called a magnetron, which works in quite a similar way to a radio tower I described earlier. It uses electromagnetic forces to generate EM waves. That was a quick explanation. Now, let us move all the way to the other side of the electromagnetic spectrum and talk about X-rays. So, how can X-rays see through your bones and how were they developed in the first place? Well, all the way back in the 1890s, a German scientist named Wilhelm Roentgen was studying cathode ray tubes. Essentially, these tubes have a wire with a lot of electrons on them which jiggle, which, as we mentioned so many times before, releases EM waves. Here's the thing. Roentgen saw the glasses was mysteriously glowing. He didn't understand why, so he put his hand on it. Because obviously that's what you would do when you discovered a new type of radiation. Put your hand on it. And he discovered that he could see through bones. X-rays developed out of cathode ray tubes. Now, how can X-rays see through your bones? Well, it's quite simple after all. You see, your stretchy skin is perfect for X-rays to go through. But when they hit the bone, it's just too tough and they stop. It's actually more complicated. As I mentioned before, you would have to deal with quantum physics and all that interesting stuff. But in simple terms, X-rays can pass through skin, they can pass through muscles, they cannot pass through bones. And the result is, on the other side, you get a lot of X-rays where there is no bone and no X-rays where there is bone. And you can invert the image to get an X-ray image. Now, that's how X-rays and cathode ray tubes work. Now, I have 2 side notes for this one. Side note number 1. Cathode ray tubes help us discover what the electron was. You see, they are EM waves, right? So that means they can be affected by magnets. They're really just beams of electrons which are hitting the glass. And electrons have a magnetic force. At the time though, no one knew what electrons was or what electricity even was made of. It's just that people knew that magnetism and electricity were connected. So an enterprising scientist named J.J. Thomson put a few magnets around the cathode ray tube and watched as the beam that they created moves. Now, he was able to calculate with a lot of maths how heavy the beam was based on how much it moved and how many magnets he was using. He found out that the beam was lighter than hydrogen. That doesn't make sense. Hydrogen is the lightest atom we know. There can only be one explanation. It's a new type of particle, the electron. Side note number 2. Nowadays, we all have digital LCD screens. But before that, we had CRT or cathode ray tube TVs. Essentially, they would use these same magnets and electron beam to hit certain phosphors on your TV with electrons, causing them to glow. And by scanning really fast up and down the TV, they could make the TV glow for one frame, and then they would change the next frame to make it glow a different picture. Put many frames in a row and you get TV. So, I hope you enjoyed learning in this journey about electromagnetic waves. In this series, we learned about radio, micro, and X-ray waves. But that's not all. There's still a lot more to be discovered. But we'll cut it off here. Now, one more question for you. Now, I mentioned Wilhelm Roentgen, the discoverer of X-rays. In 1901, what prize did he win for this achievement? Clue. You've probably heard of this prize before. Tell me the answer and I'll see you next episode.